Hi folks, I'm just going to go through this more revision. So I'm just going to be doing it live. I know it's the weekend, there's a lot of background noise where I am. So I'll just see how it goes, and I apologise for this background noise. But anyway, there's about, I don't know, 13 questions, so I'm just going to see how it goes. So the first one is it's evaluating. It's some integral. Okay, it's a definite integral because we've got numbers top and bottom here, so we're going to be evaluating that once we actually integrate. There's only one integration step here, so we might as well get rid of that now. So the integration step here is just to add 1 to the power. Okay, so 4 goes up to 5 and divide by the new power. Okay, move on to the next one. Add 1 to the power and divide by the new power. That's it been integrated here, so just move my limits over here. It's not necessary to move them over there. Sometimes people say that's just a matter of convention. And if there's anything I can simplify up top, like the 5 over the 5, they'll cancel each other out. So I'll probably do that. And so it'll just give me x to the 5 plus x to the 4 all over 4. So again, I'll just box that up there, and don't forget about my limits, and please insert the correct limits. Oh, that's the good thing about having your wee magic pen. Right, okay. So I've got that there. So that's it being integrated. Okay, that's the integration step. So what's going to happen now is we're just going to take all this stuff in here, and we're just going to copy and paste it on 2 occasions, and we're going to insert the limits here. So on the next page, that's exactly what I'm going to do, but I'm going to get rid of x and just put in a little bracket here. Okay, right, let's go for it. Let's go and get a new page. So, what did I have there? Add x to the 5. Okay, so I'm going to put that down there. And add x to the 4 all over 4. That's in there. Right, so that's what I'm saying. This is a cut and paste job here. Right, so just make sure they're exactly the same. So the only thing we're removing here is x. So I'll just go back to show you the last way. So x to the 5 plus x to the 4 over 4. Right, we'll be inserting the limits in a moment. So, but between the 2 brackets, it's always a minus. We're always subtracting. So let's put in my limits. So we're upper limit of 6 and my lower limit is 4. So in the first big bracket, 6 goes in everywhere. Okay, the x has appeared, and in the second one, it's going to be 4 everywhere. So you can put that in your calculator in one go if you want, or just keep it safe. 6 to the power 5, just fire that into your calculator. So I'm going to give you a big number, and 6 to the 4 over 4, again, that'll give you a big number there. I'm just doing this little bits at a time here. And say on 4 to the power 5, what's that? 1024. Yep, and for the 4 over 4, that's just like 4 cubed. 64. So we're just going to sort out contents of the first bracket to get 8,100. Contents of the second bracket, what we're going to get there, it's going to be a nice number there. 1088. And calculator time 7012. So that looks fine to me. So just come back to the start. You had your expression there. So between the integral sign and the dx, that was your integrand. So you integrated it using the rule. Increase the power by 1, divide by the new power for both the terms. Tidy up where possible. And that's your integration step. Next part is evaluation. 6 and 4. In the first bracket, insert the 6 in place of x, and same in the second bracket with 4 in place of x. From now on, it's just numerical calculations, and that's you. Right, bang, there you go. Okay, number 2. So number 2, so it looks like a nice little trig function here. The integral of cos 4x with respect to x. We'll just look at your formula sheet there, and so just look at the correct ones. Cos 4x. Oh, so you probably see something like cos ax, integral of that there, and it'll tell you, and that's 1 over a sine ax plus c. So that's what you're doing there. Okay, so you're looking at a formula sheet. Okay, we don't have any numbers top and bottom of the integral summation sign, so we're just jumping straight into the answer there. So here it's 1 over 4, cos goes to positive sign, and 4x is here and plus c. Please don't forget the plus c and the constant of integration, because later on if you do any more calculus, you will be going, and you might have other information, and you'll go and actually obtain the value of c, then do other stuff from there. So don't just think, oh, we're just writing this plus c for no reason at all. It's there, but we've just not reached that level yet. Okay, right, let's move on to number 3. Number 3. Okay, and so it looks like it's just going to be another basic format here. So I've got x to the negative 9, and I've got a power of 12 here. Okay, with respect to x. So look at your formula sheet. So that looks like ax plus b to the n with respect to x. So according to your formula sheet, don't touch the contents of the bracket, but can you raise the power by 1 and divide by the new power, but also multiply by the derivative, or the number in front of x, if you want to call it that. Yeah, plus c. So that's what we're going to be doing here. But what I notice here is the number in front of x is actually 1. So we're going to be fine here. So that'll be nice. So it looks as if we'll just be dividing by n plus 1. Right, okay, let's just jump in there then. Right. Always revert back to your formula sheet. Make sure you're picking the right one, matching them up. Don't mix and match formula here. So here we go. Don't touch the bracket. Increase the power by 1. Divide by the new power and multiply by the coefficient of x. Okay. Coefficient of x would be 1, but we don't need that. So all we need is a 13 there, plus c. Right. Whenever it's a plus c, it's an indefinite integral. You'll never get a definite numerical answer. So these ones are nice and easy, so there's no point dwelling on them. Right, so let's move swiftly on and see if our try trick is okay. So 4. So again, what have we got this time? So we've got 3 over 2 times the square root of x. So always watch out for square roots of x. And plus, we've got a big fraction here, and we've got 1 over, and we've got a bracket, x plus 5 to the power 4 with respect to x. Right, first thing is here, we can't integrate anything until it's in an integral form, or a form that we can integrate. So square root of x, it's old fashioned, that radical symbol, get rid of it, x to the half. Okay, x plus 5 to the power 4, it's in the denominator, it's not allowed to be there. Okay, we can't integrate it, so we have to bring it upstairs, next to the 1, and it's next to the 1, it's just 1 times it, so it just means a bracket times it. So we're just using my laws of indices here, and when that comes up there, that becomes -4, okay, with respect to x. Right, that looks okay to me. So what I'm going to do here, I'm just going to try and pull down the page here and see if I can, yeah, I think I can go from here. So yeah, first one, it's in the form ax to the n, so I'm now integrating, get rid of the summation sign, it's front and dx at the back, so coefficient is front is fine, add 1 to the power, so a half plus 1 is 1.5, or 3 over 2. That's coincidence that that's the same as the coefficient in numbers front. So I've increased the power by 1, so it becomes 3 over 2, but remember, divide by the new power. Move on to the next one, okay. Don't touch the contents of the bracket, okay, but increase the power by 1. But -4 goes up to -3 when you're increasing the power by 1, and divide by the new power. We could put on plus c here, but I won't. I'll wait to the end here. Okay, we're not quite there. So it looks as if we could do a wee bit of tidying up here, and it looks like that over that. Looks like those two parts would cancel. They would indeed. Okay, so that's what I'm going to do, and so that would just leave me with x to the power 3 over 2, and over here, plus and the minus, I'm just resolving the signs here. So the plus and the minus, positive and negative, whatever you want to call it, you call it whatever you want, I'll not go upset. So I've got negative x plus 5 over -3 all over 3. I'm just going to put a plus c in there. Right, my answer's fine to there, but some of you might want to change that. You might not like to have negative indices. So if that's the case, you can go for that there. So x to the 3 over 2, when the 2 is in the bottom, that's a square root of x cubed. So that's the top power for the fraction. So I could write it like that, and I could bring this part downstairs because it's got a negative index or power, whatever you want to call it. Take it downstairs next to the 3. I think I'll keep that as negative. We'll just leave a 1 up there because I'm bringing the entire thing downstairs. We have 3 there, and that's going to be x plus 5. And change the sign of the index of the power. But a lot of us say that with this one here, it is fine to there. So if they're telling you it's fine to there, then leave it. Okay, just leave it alone. But if you're comfort with your index notation, your old radical notation, that's the things that you call square roots. And you could just put it like that there. Right, so remember, you can rewind the video and just go back and try and figure out what this guy's talking about here. And again, don't forget about the plus c, the constant of integration. You never know, you might pick up a mark there. So what was that? That was question 4. Okay, question 4. So it seems like that kind of seems to be like a kind of integration section out of the way. So okay, this is not an in-depth tutorial here. I'm just trying to go through the solutions here. This one's all about differentiation. So it's a derivative of, it's a trig function sine in the bracket is 5x take 3. Look at your formula sheet, and so for f of x, so I'm going to use a dash notation here. I think it asked me to use it. So the 5 is going to come out the front, okay, and I think sine goes to cosine. Well, I don't think, I know. So it's going to be 5 cos, and leave the contents of the bracket alone. And no, you don't put a plus c on because we're differentiating. Right, that's fine. Let's move on to question 6. Question 6, what have we got? Ah, yeah, that's fine. Okay, it's x take away 8 all to the power 6 here, and it's asking us to differentiate. Use whatever notation you want. I'm just going to use the lazy notation y dash. So the number in front of x is 1, but look at your formula sheet, because this is of the form ax plus b to the n. And when you differentiate that there, you bring the power down in front, multiply by the number in front of x, leave the contents of the bracket on their own, and subtract 1 from the power. But because 1 is a coefficient of x, it's not going to affect the power when you bring it down. Okay, so here, let's differentiate, bring the power down the front. Yes, it would get multiplied by 1, wouldn't change it. It's going to be x take 6, subtract 1 from the power, so 6 take 1 is 5. There you go. So that's just you using your formula sheet there. Right, 7. Well, we're fair whizzing through these. So well, this one here, it's not going to be as straightforward. Well, they like using these square roots of x, okay, and they like putting x in the bottom with the power. So here, it's not in a form that we can actually differentiate it yet. So here it's going to be 16x to the half, and we need to bring that x to the 7 upstairs, and when we do that, we'll be 1 times x to the 7, but it won't be, we have to change the sign of the power. Now we're ready to differentiate it. It's asking for the form dy by dx. Here we go. So it's going to be a half times 16, that's just going to give us 8 there. So 8 times x, and a half, take away 1 there, is negative half, that's fine. Next part here, I'm just going to bring the negative 7 down the front. It's really a 1 in front of x, so that's fine. So that's just going to be negative 7x, and subtract 1 from the negative 7. So remember, negative 7 equals to negative 8. So, like I'm saying, that's fine to here. Okay. There's no point digging a hole for yourself. Leave it if you want. But for those who want to change things, 8x to the negative half, well, x to the negative half, we could bring that downstairs, it'd be 8 over x to the half, and then we could just write it as 8 over the square root of x. Okay, I'm not going to spend all day in that. And here, we could just take x to the negative 8 downstairs and leave negative 7 upstairs, or just put the negative 7 at the front. So I'm just going to have that as negative 7 over x to the 8. But like I said, here, that's fine. That's just or. But you don't want to just do too much. Right, so I think that was okay there. Or was it? Right, so I'm just going back here just to make sure I've not missed any out. Okay, that's fine, that's fine. Right. So that's the danger when you're ploughing through these so fast. There is a tendency that you might miss some out. So I think, yeah, I'm okay with that there. Right. I'm sorry if you can hear the fireworks going off in the background, but I don't know, apparently they're cheaper this time of year. Right, okay. Let's go for it. Right, that's us over halfway through here. So, question 8. So, what have we got here? Question 8. So, we're trying to find a tangent to this curve here. Right, so you've seen the question. Okay, so what we've got here, so x equals 2, what I'm going for here, well, if I sorted that out, yeah, I know that the colon should have been at the end. I'm overthinking things here, so x equals 2, y equals, so in place of x, I'm just putting 2 everywhere, so we're going to have 2 going in there, and 2 going in there, that's fine, okay, so 2 there, 2 there, and then we tidy up, so 2 squared is 4, 3 2s are 6, and 2, so 0, so here, when I fire that in, that threw up a point of contact, so when I put in 2, it threw out 0, so 2, 0, so I'm going to be using a formula later, so I'm going to call that AB. Right, okay. I'm going to try and fit things in here, so I'm just going to box stuff off here, and I'm going to go and get the gradient there. I can see I've got my function there, so I'm going to go and get the gradient. Well, the gradient is m, but really it's a change in y over a change in x. It's coming from the derivative of that thing there. So when I differentiate that there, I get 2x take 3. Okay, but the x value, it's 2 again, so x equals 2. I can just fire in that value there. So I'm just getting rid of my value of x, put a wee bracket, 2 2s are 4, take away 3 is 1. Okay, so I've got my gradient there, that's fine. Right, okay. Right, so what I'm going to do now is it's equation my line here. So I'm just going to use y minus b equals m x minus a. So that's just one of the formats that you can use. So I've got m equals 1, and that's my point of contact there. So that's what I'm going to use here. So let's put it in. So I've got y minus b, which is 0. Okay, m happens to be 1. I'll just put that in there. And I've got x minus a. X minus a is 2. Put that in there. 1 times the bracket is just the contents of the bracket, and y takes 0 is just y. So that there is the equation, okay, to my little parabola there. So that's what I've worked out there at that contact point. But we don't need a picture, but basically that's what we've done there. So that's our answer, and we're fine with that there. I hope. But pictures are good. You can use them to help you, actually. So question 8, let's move on to number 9. Number 9. We're moving on to trig here. Okay, so let's see. We've got 26 minutes here. I'm just going to pause that there. Okay, so just checking my time there. So that's nearly 27 minutes for 8 questions. That's less than. I don't know, I'll let you do the math. So it looks like we're coming on to a trig section, so that can be quite tricky. Well, I can make it tricky. So here, what have we got here? Sin 2x, take away a half sin x equals to 0, and usually they tell you where you're allowed to have your answers. So this is a kind of standard one that some people might go with. Some people might include 360, whatever, but just watch out for that. So here, it's just sin 2x. This looks like double angle, so we need to find the expansion for that. Look at your formula sheet. There's only one, so that's 2 sin x cos x. That's expansion, the substitution here. Take the replacements. Anything else, don't touch it. Okay. We've got the replacement there. The reason for that is because it's all in terms of single x, in terms of sine and cosines. So what we're looking for here now, we get two separate terms equal to 0. We need to have a product of 2 or more terms here. So we're looking for a common factor. So it looks like we'll get sine x, sine x. So we're going to factor that out here. When we factor out, just take sine x to the front. Open up a bracket and see what we've got left. So we've got a 2 and a cos x from here, and we'll get negative half from there. Okay, right, so let's go for it. So what do we say? 2 cos x, take a half equals 0. Right, the only way that's going to work, you get a product of two things. That times that equals 0. Only way that's going to work is if the first one is equal to 0 and if the second one is equal to 0. So you get sin x equals 0, or 2 cos x take away a half is equal to 0. So here, when sin x is equal to 0, because I know where my answers are here, what I'm basically doing is I'm going with my knowledge of the graph here of sin x. Where does it equal 0? Where it cross the x axis between 0 and 360 and not including 360. So that there, that's just at 0 and 180. So that's how I know how to get my answers there. Because the quadrant check doesn't deal with 0 here. So we've got my two answers here for x. That's actually 0 and 180. Okay, so that's half it done. But 2 cos x take away a half. So that'll be 2 cos x equals a half. And that's cos x equals a quarter, because I'm dividing both sides by 2. Could do that there, but right. So what I'm going to do here is, yeah, I know I'm going to come up with answers for cos x equals a quarter, but what I wanted to do here, cos x equals a quarter, that's actually positive. So the question is, where's cosine positive? And that's in relation to the quadrant check. So all sine, tan, cos. So where's cosine positive? That was positive in all in cosine, because we're dealing in degrees here. I could put x equals a, but I'll just put a and 360 minus a. Okay, so that's what I'm going for there. Right, so where's this a coming from? Well, a is a calculator answer. So what I'm going to do is, so I'm going to let cos a equals a quarter. So that means a is inverse cosine, or use all say cos to the minus 1. Not use all, but some of you. So I'm just going to go for one kind of decimal place here. 75 and a half, I think it is. Right. So that there is my calculator answer, because you can't solve it directly for x, because your calculator only has one value. Right, so that means for x, yes, it is a, and also it's 360 minus a. So that's where we're coming down here now. So yes, I'm probably changing from my usual format. So it's 75.5, and the other one's 360 minus that. What's that? It's 360 minus that. That's 285. No, 284. Yep, 284.5 here. So that kind of looks okay. So I'm just going to just bring my solutions together here. I'll just put them in. So I'll get 0 degrees, 75.5 degrees, 180 degrees, and the big one's 284.5 degrees. That looks okay. Right, just going to check that. To me that looks like a 6, so I'm just going to change that to an acceptable 0. So it looks like I'm kind of done there, and I just check that my answers do kind of lie between 0 and 360, and okay, because that's where they want the answers, between 0 and 360, and it looks like those answers do indeed lie between 0 and 360. Right, so I'm okay with that. Right, question 10. What is question 10? Right, question 10. So I'm trying to get this done in under an hour here. Question 10, 4 tan 3x plus 4 is equal to 0, and it looks like it wants the answers between 0 and pi. Right, working in radians here, danger, danger. Right, so let's go and rearrange this equation. See here, so we get 4 tan 3x equals -4, and let's divide by that 4. So we'll get tan 3x, -4 divided by 4 is -1. Okay, danger, danger, negative here. So we've got tan 3x equals -1. So I need to ask, so where is tan negative? That's we're talking about a quadrant check. That's if you're using a quadrant check, or you might have somebody else who uses another method, a method of symmetry. So where's tan negative? Well, so that's my so all sine tan cos. So where's tan negative? It'd be positive in all in tan, so it's going to be negative in sine and cosine. Right. Right. You always need to ask that question. I'm going to work in. Am I going to work radians here? No. In the written solutions, I've done it in degrees. So what I'm going to do is, no, I've worked in radians. So what I'm going to do. Right. So this is a wee bit different to what my solutions were in my handwritten kind of solutions. Right, so that's all. Right, because a lot of you can't cope with fractional values. So if I'm working degrees, that means that because it's 0 to pi, you need to reflect what that is in degrees. So in degrees, that would be 0 is less than x is less than 180 degrees. Okay, we'll bear that in mind, but I'm going to get rid of that there. But you can always rewind that. That's a good thing about having a wee video here. So I'm going to work in degrees. It's always good to give people options. Right, so that's why I'm doing this actually. Right. So I'm now I can go back into my quadrant and then just work in degrees here. So in here, if it's sine, it'd be 180 degrees minus calculator answer, and over here it'd be 360 degrees minus calculator answer. That's fine. So that's what I'm going to be working with once I find the calculator answer. So in order to go and get the calculator answer, I've got tan 3x equals -1. We're not allowed to use negative here. Be aware of that. So get rid of 3x and bring on tan. Tan is a stunt double, okay, for whatever you're working with. So A is the inverse tan, okay, inverse tan of 1, and inverse tan of 1 in degrees is 45 degrees. That's fine, okay. That's us done that part here. So we are going to relate that to our quadrant check. So we've got 180 minus A and 360 minus A. Right, but we're not talking about tan anymore. We are talking about 3x, so we need to bring 3x back. Okay, so when I bring 3x back here, so we'll get 3x equals 180 minus it, so that's equals 135, and 360 minus that is 315. Okay, so let's go and solve for x. Let's divide both by 3, and it's at 105. Right, that's fine. Okay, that's fine. But because it's 3x, what I need to do here with these two solutions, we need to go up to 360. So what we have to do is we have to add 360 divided by my x number. Okay, and my x number is 3. Right, so it's going to be 3x divided by 3. Some people call that the period, whatever, but it doesn't all work with tan, but it works out in the end. So I'm going to be adding 120 in pairs. Okay, and just to make sure you can see that is a 3. So we're adding 360 in pairs here, folks. Right. Right. So it's 45, 105, and we're adding 120. So I'm going to get 165. Okay. Then 105 add 120, and I'm going to get, what's that, 225. And then 165 add 120 is 225 there, and final 225 add 120 is 345. Right. So it looks as if that's my answers there, but it's not really, because I'm operating in this zone here, and in degrees, that part there is 180, and the 0 is 0 degrees, so I need to go check which parts are allowed here. So I think only those values are allowed there. So and again, you can rewind the video here just so you can see why I'm getting rid of some answers here. So what I'm going to have here is x. So that's, they are the only 3 values that are allowed. Okay, that's fine. But yet again, I'm working in radians. So so what I need to do here, I need to convert to radians. So what I need to do with all my angles in the degrees is I need to multiply by pi and divide by 180 degrees, okay, for each one of these values here. So that should be fine. 45 degrees. Right, it's going to be over 180. It's really the 45 over 180 that you want to simplify as a fraction. It's going to pi stock to, that's fine. And then again, 105 degrees over 180. That's what you put in your calculator, 105 over 180, stick pi in it. And again, 165 degrees over 180. Simplify that and stick pi in it. So if we just fire through that, so it's 45 over 180, that gives you a quarter. So 1 pi over 4. So we're going to have to get that's going to be pi over 4, 105 over 180. So 15 goes into both, but that's fine. Just do 105 over 180 in your calculator, see what it gives you as a fraction. Just give you 7 pi over 12. And the last one there, 165 over 15, that's 11. Yeah, 11 pi over 12. That's the three solutions in radians. Okay, so if you like degrees, you can do it in that format. And like I said, remember, you can rewind this video because I've erased some stuff here. But that is your final answers in radians, and just check that they all fit between 0 and pi. But we checked they fitted between 0 and 180, which is the degree equivalence here. So I think I'm fine with that there. Right, so that's question 10. Nearly home and dry here. Nearly home and dry. Right. Oh, I'm sorry about the length of this video here. So I think that's a trig out the way. Well, it's not quite. So I think I'm going on to I'm going to question 11. It's still in the trig zone here. Of course, sine squared x, take away 1 equals 0. And what does it want my answers here? Oh, and so it wants them between 270 and 360. This means I try to make it easier for you. Okay, so that seems like that's only one quadrant there that I'm looking for. Okay, so let's rearrange that there. So 4 sine squared x equals 1 sine squared x equals 1 over 4. Remember, because you're square rooting here, we need a plus or minus the square root of a quarter here. And you square root a quarter, square root at the top, you get 1, square root at the bottom, you get 2. So what we're looking here is sine x equals plus or minus a half there. That's okay. And well, in terms of the quadrant, so they're asking where is sin both positive and negative? Right. In terms of quadrant, both positive and negative, all sine, tan, cos. Well, it's actually going to be positive in all four there. Right, so there's a possibility of 4 answers, but we need to go and sort out this part here because we get positive and negative half. So we need to bring on board the stunt double. So I'm just going to bring it down the page. So what I'm going to do is, as usual, let sine A equals a half. So A is inverse sine of a half. Inverse sine of half in terms of degrees, it's just 30 degrees. Right, okay, that's fine. Right, okay. So we've ticked 4 quadrants here. But what I can see is the solutions, they just want to go between 270 and 360. So really, I'm in here. Let's say 360 minus A. Okay, so that's actually what we're looking at here. So 360 minus A. Right. Okay. So that means I only actually have to use that there because I am between 270 and 360 there. Right. So that's it. Just take your calculator answer and use 360 minus A. Um, and that's my final answer. 330 degrees. And again, because I'm scrolling up and down the page, you just need to go back here, just rewind and see how you go on. Right, I think I've only got 12 questions in this, so am I going on to a new topic here? Right, let's see. Just check time there, 50 minutes. Just going to bring that up. I'm just going to pause that there. So, number 12, right? No, as a change of topic again. So we get some kind of quadratic expression here, and they're asking I'll just write this down. You should be reading the question paper in conjunction with this here. Right, so I'm going to write that and then I'm going to get rid of it. So for what values of k does the above expression have no real roots? So there's the value of k, so that's an unknown there. So I'm just going to get rid of the rest of that there because you have the advantage of rewinding. Okay, so what values of k? So I think I need to make a wee statement here. Discriminant has to be less than 0. So discriminant here is that thing there. B squared take 4ac has to be less than 0. So we need to know what the values of a, b, and c are. And they come from here, here, here. So you know that's a 1 there. Right. So here, A is 1, B is k, and C is a number on its own. That's fine. So we'll just put them in there, keep them safe. So we'll go back to our discriminant there. I'm just going to fire in the appropriate values here and see how everything turns out. So what we're going to have, so B, that is a k, A is 1, and C is 16. So when I start figuring things out and moving all these brackets, I'm going to put k squared, 4 times 1 times 16, that's 64 is less than 0. That's fine. Okay, so stop there. So k squared take away 64, that's actually a parabola. So I'm going to solve this graphically. So I'm going to pull up the parabola first of all. So I'm going to see if I can get right. I'm not having a good time with my parabolas here. Right. Okay. I'll kind of go for that. No, no, no. I'm not happy. I'm not happy. Not happy at all. Right. Okay. So, so that's kind of that's k squared take away 64. You can call it y equals or whatever equals. That's k. That so, and I noticed that way up because k squared is positive. Right. So where's k? Where is that? Less than 0. Well, I'd need to know where I had a k-axis. Okay. So is it there? Is it there? Is it there? I don't know. I don't know. Okay. Well, I do. I do know. So, um, because it's k squared take away 64, I know I can factorise that, so that's what I'm going to do here. So, I'll get, that's the difference of 2 squared, so it's k plus 8 and k minus 8 is less than 0. Right, because that's factored into 2 linear terms, that means that here, there's definitely 2 points for the parabola crosses. So those 2 points, I've got one there and one there. They are related, like I said, to be these values here, like positive 8 and negative 8. Change the signs of these, right? Just change the sign. So what value would you give to k to make k plus 8 0? Well, negative 8. What value would you give to k to make k negative 8 0? Positive 8. So that's how I am getting these values here. Okay, so we've got negative 8 and positive 8. That's the k-axis. Okay, so, but they're asking the question, where's k squared negative 64 less than 0? Which parts of the parabola are below the k-axis? That's what they're asking here. Which parts of the parabola are below the k-axis? You're talking about this part of the parabola here. It's below the k-axis. That's what they're talking about. So which values of k fit in with that? Well, anything between negative 8 not inclusive all the way up to positive 8. That's what they're talking about here. So k, we k, that's too big a k. So k seems to be rattling about between -8 and +8. Right, that's what seems to be happening here. In fact, that is the solution here. That's what's really happening. That's where it's below the k-axis. So that is our solutions here. So it's going between -8 to +8. So the way I write it now, these are my bookends. -8 to +8, okay? K's in the middle. And like I said, K is wrong, so it never actually reaches -8 and it never reaches +8. It's less than 8 and it's greater than -8. Okay, so less than 8 and greater than -8. So we just write it this way. The inequalities always point to the left here when we have a closed interval, i.e. K is bounded, okay, between -8 and 8. So that's our solution, folks. Okay. That is our solution for this question here. Right. Okay. Whew. Final question, hopefully. 13. 13. Oh, this is it's one of these polynomial ones. Okay, so what have we got? Got a polynomial on x. X cubed plus x squared. Take away 49x. Take away 49. Right. 49. Okay. So there's a few things going on here. So the first part is to show that x plus 1 is a factor. So x plus 1 is a factor, then the polynomial evaluated actually at -1 must equal 0. And so that's exactly what we're going to do. So we're just going to fire in there. And hopefully come up with an answer on 0 there. So it's going to p of -1. So -1 cubed is going to be -1. -1 squared is going to be +1. Negative times a negative is a positive. That's 49. And -41 at the end. Oh. So the whole thing now comes out to 0. So we can just need to make a statement here. There is another way we could do this, and that'll probably come in the next part here. So the next part is actually to fully factorize p of x. So p of x, I'm just going to write it down again here. Okay. So I'm going to use synthetic division because you haven't been shown polynomial long division. And I'm going to use x equals -1 here. So I'm going to set that up. So get -1 here. That's, I call that multiplier. So I'm just going to read off the coefficients. So I've got 1. I'll use a different colour pen here. I've got 1, 1, -49, -49. So I'm going to read them off there. And there we go. 1, 1, -49, and -49 there. Okay, sorry if you can hear my neighbours at the back door. They must be celebrating something. I don't know why. Right, so here, -1's my multiplier, but what I need to do is I need to drop down the 1 first. Okay, it comes below the line. Once it's below the line, it automatically gets multiplied by the multiplier. So -1 times 1 there, it automatically gives me 1 there. And sorry, it doesn't give me, it gives me -1, because the next thing I'm going to do is add these two. And see, when I add them, I get 0. And right away, as soon as it's below the line, it's open to get multiplied. So -1 times 0 is actually 0. And that goes up there, and right away I add these. See, bring my result down there. As soon as the number's below the line, it automatically gets multiplied. So -1 times -49, it's going to be +49. So it goes up there, and yet again, they get added -49, add 49. It's going to give me 0 there. That's fine. And so just quarantine 0, that's what I wanted. So what I've actually found here is, upon dividing by x plus 1, what I've got here, these are the coefficients of my quotient, which will be 1 degree less than what we started with, which is x cubed, so it'll go down to x squared. So here, that'll be 1x squared here, so 1x squared plus 0x take away 49. That's what we've got there. Or we can just write it as x squared take away 49. Okay, so that there's known as the quotient. Doesn't matter if you know its fancy name, but that's what it is there. So let's move on. So we divided by x plus 1, and we get a quotient of x squared take away 41. So that tells us something about p of x. So we're just continuing the b here. So I'm just going to write it from the start here, just so you can see. So upon division by x plus 1, it threw back at us a quotient of x squared take away 49. And this part of the question is actually to fully factorise. So x plus 1, that's a linear factor, we were told that. But x squared take away 49, that's the difference of 2 squared. So x take away 7, x plus 7. So that's sorted. Right, we're nearly home and dry. Question C, question C. So for question C, or part C of question 13, something like that here. So solve p of x equals 0 for x. So We've already factored p of x, okay? So I can see so why don't I just go for x plus 1 x takes 7, x plus 7, that's equal to 0 here. So that means that x plus 1 is equal to 0, or x takes 7 equals 0, or x plus 7 equals 0. So what we've got here is x equals -1, or x equals 7, or x equals -7. There's no reason, you don't need to put these in order, folks, okay? No reason to put these in order one wee bit. So what I'm going to do here, I'm going to finish that there, because it's getting too late, okay? And, oof, right, that's taking a long time. Right, bye for now.